Hi folks, it's Mr. Devay. Welcome to an edition of Special Right Triangles. In this video I'm going to show two examples specifically about 45, 45, 90 right triangles. And so let's go ahead and jump right into it. A 45, 45, 90 right triangle is exactly what it implies. You have a right triangle, which is where the 90 comes from, and then you have the 45-degree angles, which are the other two. Now, what this means is several things. First of all, it means that this is not only a special right triangle, but it is an isosceles right triangle. And I know that because the remaining two sides after the 90 degrees are both congruent, 45 and 45. So when base angles of a triangle are congruent, that means automatically that you have an isosceles triangle. Not always an isosceles right triangle, but in this case we do have an isosceles right triangle. So that also means that both A and B, these two legs that you see here, A and B, those two are congruent to each other. Okay, so I'm just going to write down these facts to characterize what we're dealing with. So some properties to keep in mind are the following. Number one, A is congruent to B. Okay, or I should more specifically and correctly say A is equal to B, since those refer to the lengths of those sides. And also this is an isosceles right triangle. Okay, side C is always the hypotenuse, which means that it is automatically the longest of the three sides of this triangle. And with the 45, 45, 90 triangle, there is also a special way of showing just how much longer it is compared to A and B. So what would be good to know here is that C is exactly radical 2 times, or actually I'm going to write it this way. C is this much longer than either A or B. Okay? And if I were to turn this into an algebraic statement, it would look just like this. It would say simply that C is radical 2 times longer than either A or B. And I have to choose one or the other when I'm writing my equation here. So I'll go with A. And again, it doesn't matter since A and B are both the same. So if I rearrange this, what I get is, in a shorter form, C is equal to A radical 2. Now, rather than memorizing this, try to understand this, because logically it makes so much more sense. You know that the hypotenuse is the longest side, but depending on the kind of triangle that you have, meaning whether it's 45, 45, 90 or some other type, 30, 60, 90, the length of C will be a certain amount longer than either of the legs. Now in this case, because A and B are both congruent, we can use them interchangeably. But specifically for this type of special right triangle, C is exactly radical 2 times longer than A or B. To put it in more obvious numerical terms, radical 2 is about 1.7 or so. And so you could say that C is about 1.7 times longer than A, which if you round it off is almost like saying it's almost like saying it's twice the length of A. But in this case, we should not nor ever round off that radical 2, because it's a very specific amount that we're dealing with, and we have to be precise. Okay, so let's go ahead and jump right into example 1. In example 1, we can use the properties that we just figured out here about that relationship between the hypotenuse and the legs to answer this question. Now, in this question, we have two unknowns, which happen to be both of the legs of this triangle. But I notice that this 45 degrees is a dead giveaway about the type of triangle we have. Because this is a 90 degrees, I know it's a right triangle. Because that's 45 degrees, I also know that this is also 45 degrees. It has to be. It cannot be anything else because of the triangle angle sum theorem. And so what I need to do is try to organize my thoughts into how will I lay out the equation to figure out my x and my y. Well, again, if you think logically about the relationship, it goes like this. It would be the hypotenuse is this much longer than a leg. Now, if I translate that, it would be the following. The hypotenuse, in this case, is my 4. Radical 2, well, that just stays the same. The word times, that's pretty obvious. And then longer than a leg. A leg, this part, a leg, that comes all the way over here. A leg, I can decide what I want. X or Y does not matter since they're both congruent. So I will go with Y. And if I rearrange this, it looks like this. It's Y radical 2. And now I have a short equation that I need to solve to figure out the value of Y. Okay, so I'm going to use my division property, dividing by radical 2. What I get is the following. I get that Y is equal to 4 over radical 2. Now, if you remember from algebra, we need to rationalize the denominator anytime we have a radical stuck in that denominator. And to do that is as simple as multiplying with a fraction that really is equivalent to 1, but we have to multiply by radical 2 and radical 2. So what I get is 4 radical 2 over 2. And now that this 2 in the denominator is free, I can simplify these two. Oh, that looks horrible. Sorry about that. I can simplify my 4 and 2, and I get, pardon me, I get 2 radical 2, and that would be my answer. Now, I have to remind you that x and y are both the same value. So now that I have the value of y, I automatically know the value of x, and I can write my answer as follows. I can say x is equal to y, which is equal to 2 radical 2. And with that, we are done. Okay, so this relationship about the hypotenuse length being radical 2 times longer than either leg will always apply to a 45, 45, 90 special right triangle. Using that as a basis, you can solve any question related to these types of triangles, no matter how complex looking the numbers are that you're dealing with. And I say that because of example 2 coming up right over here. Now in example 2, we have a leg with a value of 3 radical 2 over 2. Now, that doesn't make a whole lot of sense. It would make a lot more sense if this was put into a decimal form, but it's not. So we have to keep what we have. And so I'm going to go ahead and lay out the idea again. The hypotenuse equals radical 2 times longer than a leg. Okay, and I only do that for my sake. In my head, when I write it out as an equation, I already do the translation. This is really for you to get used to the idea of understanding rather than memorizing, which will make this information stay in your head a lot longer. So our hypotenuse in this case is not a numerical value. It's the letter x, the variable. Again, radical 2 is still the same. Times, pretty obvious. Now, and then the leg part. Now the leg, in this case, we know that number, and it is 3 radical 2 over 2. And remember, x and y are equivalent to each other. Excuse me, not in this case. Y is equivalent to the other leg. So this is also 3 radical 2 over 2. Okay, so I already have one part of my answer right here. And I'm trying to figure out the hardest work of this question is to just figure out the value of x. I'm going to go ahead and multiply these two. Keep in mind, when you multiply something that is not a fraction with something that is, it makes a lot more sense to take a radical 2 and put it over a 1 and then multiply it with something that is already a fraction. Because in doing so, you know that these are at eye level, these are at eye level, and they multiply sideways to each other, in that way. So what we get as a result is the following. We get x is equal to 3 radical 4 over 2, which when you look at that radical 4, that's a perfect square. So this is now 3 times 2 over 2. And then these two 2's eliminate, and I'm left with my answer, which is 3. Pretty simple answer considering the fraction that I had to work with. So my x value is a 3. And with that, this question is now done. So the foundation for answering these 45, 45, 90 special right triangles is just to understand the connection between the hypotenuse and either of the legs of that triangle. If you can understand that it's longer by that amount, and that radical 2 represents an amount by which it's longer, then you don't have to memorize anything, okay? I hope this video helped you out. Look for my next video, which will be about the 30, 60, 90 special right triangles, and that will be featured very soon in the future. So take care, please stop by, leave a comment, and I hope to see you again soon. Bye-bye.